Hi everybody, we have completed discussing about List ADT and we have also done the implementation of List ADT using arrays in C as well as C++. In this video we are going to discuss about how was array implementation. It is very comfortable. We have done all the operations and why should we go for linked list and what is the analogy for both the implementation, so that we will understand better. That is the objective of this video. Let us just recall the time complexity that each of the operation in array implementation had. So when you look at the create list in array implementation, what we were doing, we had actually three members. One is the elements array, other one is the number of elements, and other one is the capacity. So we just initialized, we dynamically allocated memory for the elements. What we did was we were getting the capacity from the user and then we were allocating the memory. So the complexity involved is big O of 1. That is, it does not depend on the number of elements in the list or any other factor. So it is going to take constant time. That is what we mean by big O of 1. And then we wrote a destroy list function in which we were giving back the memory, dynamically allocated memory. So the destroy list function also took big O of 1, constant time only. And next is the print list function. In print list function, what we were doing was we were just traversing the array from index 0 to number of elements and we were just printing it. So it depends, the time taken depends on the number of elements in the list. So the complexity we can tell as big O of n. And then we were checking whether a list is empty. For that we were using just the number of elements and we were printing. So it would take constant time only. So it is big O of 1 is full also, just comparison of number of elements in and the capacity of the list. So big O of 1. And then we wrote the insert beginning. In insert beginning we have to shift all the elements one place right when we have to insert. So the complexity will be big O of n and insert at the end. So when we want to insert at the end, we will just put the element at the end and we need not do any other operation. So the time taken will be constant. Next is insert at the position. When we look at insert at the position may also be the first position or in between, but anyway we have to right shift all the elements by one position. So obviously it depends on the number of elements, so the complexity will be big O of n. Similarly, delete beginning will be big O of n, delete end is big O of 1, delete at a given position is also big O of n, since these two operations involve shifting of the elements. And then we wrote a locate function. Actually the locate function will take the element and search for it. Basically it is like a linear search, so the time taken will be big O of n. And retrieve function. In retrieve function we will be given the position and we have to find out what element is present in that position. Actually random access is possible in list, not in list, arrays, right? Since array supports random access, it is very easy to retrieve the element using the index. That is okay. Fine. Now we have discussed about arrays and how about the operations. Next, let us try to have a different understanding. Let us consider that your family is going to organize a marriage and you have been given a responsibility that you have to arrange accommodation for all the guests. Okay. Let us assume that you have distributed like 200 invitations. Your family has distributed totally 200 invitations and they are expecting 200 people to come from outside. All are going to come from outstation. Now we have to arrange accommodation, right? So one of the idea is book 200 rooms in a hotel before a month. Okay, before some time you will get you will go and book, right? 1 month or 2 months, whatever it is, you are going to go to a hotel and you are going to assume that it is a big hotel having some 500 rooms or something, and you are going to book 200 rooms. Okay, so and you ask for them, you want the continuous room numbers. Okay, so you say that I want from room number 101 to 300. Like this you are telling that you want continuous room numbers, 200 rooms. Yeah, it will be given. There is a high chance that you will be given those rooms on the dates in which you book, right? So what is the advantage of this? Definitely you are going to have rooms. There is no need of worry. and the room numbers are going to be continuous. So whenever you want to do something for your guest, for example, if you want to supply coffee for all your guests, you are going to ask the serviceman to provide coffee for all your guests. Then what you can do is, since they are residing in the continuous rooms, you can just say room number, starting room number, that is 101. You can tell the bearer that from 101 up to 150 you provide 1 cup of coffee or some 2 cup of coffees. Like that you can tell. It is very easy to access. Okay. If you know the starting number alone, it is enough. You can find, for example, if you want to know where your 10th guest will be, obviously they will be in 110. If you know the starting number, it is easy to compute, isn't it? Suppose if the starting number is not 101, if it is 120, then where your guest will be? Your guest will be in 129. 10th guest will be in 129, right? Like this we can find out the people also easily. These are all the advantages of having rooms continuous like this. Okay. And what is the problem in this? What is the trouble? Whether this is okay, fine, good? No, there are certain difficulties in this. Problem is when less number of people come for marriage. Okay, you are expecting 200, but only some 20 people from outside comes, right? Then there is a lot of wastage, and you have to pay the hotel because you have already booked the rooms, isn't it? So actually it's a trade-off. What you have to do, you may be thinking of booking only, okay, I will book only 50 numbers. If suddenly 80 people turnovers or 150 turnovers, how will you manage the accommodation on that day? That may be very difficult, isn't it? So this is the advantage and drawback for going for this particular way of allocating memory. Okay, this is equivalent to allocating memory for storing your elements, right? Whatever we were writing in the main part, actually you may not be the user. Whatever we write in the main part is the application of the list. We will be discussing about more applications in the forthcoming videos. So that is the application part what we write in the main, and sometimes the person who is developing the list and who is writing the application may be totally different, and he may not know, each other may not know their dependencies, and it's difficult, right? That's the challenge when you are going to go for these kind of implementation. So what is the second area? Let us come back to the analogy, and now what is the second idea? What can I do if this is going to be a lot of waste of money and I may be in trouble? If I book less number of rooms, if more guests comes, then I'll be not providing them proper hospitality. That may create some kind of ill feeling. I want to have a good feeling. I want to give a good feeling for my guests. So what can I do? The second idea may be like, you can check in a hotel for its predicted capacity. Okay, how much you can, how many rooms you will be having on that particular day. For example, if they tell we may have 200 free rooms, but they cannot give assurance. Okay, it's not assured that there will be 200. You are just inquiring, and based on their experience, they may tell, okay, 200 rooms may be free on that particular day. And what do you plan is, as guests arrive, you are going to book the room and you are going to accommodate them in a room, right? As guests come, one guest comes, then you will book room. Another guest comes, you will book the second room, like that. You are going to plan, okay? So what is the advantage of this? There is no wastage of money at all. If 15 people are going to turn over, you are going to book only 15. If 57 people are going to come, then you are going to book only 57. Exactly, you are going to match the things. But what is the difficulty in this? There is no assurance of rooms, okay? It may not be available, that is the problem, and room numbers may not be continuous, will not be continuous mostly, because your guest is not going to come together, right? Your first guest may come by morning 6 o'clock, your second guest may come by 6:17, your third guest may come by 6:32, fourth guest may come by 6:35, like this, okay? In between, so many people may come into the hotel and they may occupy the rooms, right? So your room number may not be continuous. In that case, if you want to provide a service or if you want to give something for all of your guests, how can I do? Take the case if you want to supply coffee for all of your guests, then what can I do? So there may be an idea like this. What you can do is, this is just a idea, right? You can just remember only the first guest room. For example, if the first guest is at room number 115, you will just remember only 115 and you will call the bearer and you will tell him that go to 115, provide coffee, and the person there, the guest there will be having the next guest number, okay. What I mean is, if the room allocated are 115, 121, 130 like this, okay. So the person in 115, your guest in room number 115 will be having this number 121. You will not remember all the numbers because that is very difficult, okay. So instead all of your friends and family is only going to come. So you make a request like you have to remember the next room in which the friend is there, okay. So the person, the serviceman will go to 115, he will provide coffee to that person and he will be asking what is the next room number. He will be telling 121. Then he will go to 121, provide coffee and ask him what is the next room number. He will tell 130, right. So in 130 he will do the same. If the person in the 130 is the current last person, okay, till no more guest has arrived, means he will tell I do not have a room number. In that particular thing, the bearer will stop providing the coffee like this, okay. This is the idea. So when you look at it, yeah, advantage is there, and what is the drawback? Maybe what you can feel is there may be a delay in providing the coffee, okay. If it is continuous, he can easily go there and provide, right, and if it is not continuous, like this means he has to find out the room number and then he has to move so many, see the gap is there. From the first guest to the second guest he has to go, means there is a gap. So the speed of the operation may not be so good as we are having in the first case, right. And then what may be the other difficulties that you have to face, right, that is keeping, for example, I cannot do randomly, I cannot find my nth guest. Previously I was telling you, if I want to know the place of the 10th guest, I can just add with the first room number, I can locate it, right, that is possible. But in the case of this idea, you cannot do like this. If you want to locate your 10th guest, you have to get the, you know only the first guest room number, you have to traverse like this, you have to get the room number of the second, you have to get the room number of the third, fourth, fifth, like this you have to go, then only you can locate the 10th guest, right. So no random access is possible in this case, right. This is how a linked list is going to be implemented, right. And let us look at the memory required for storing the elements and the time complexity. Already we saw the time complexity for array implementation. We will discuss for linked list implementation when we do it, right. Time complexity will be almost like same, like in beginning here you are having big O of n, there end will be big O of n, beginning will be big O of 1, right, like that only. There won't be much difference in the time required in the operations when you see together. When you see everything together, there is no major change, right. But look at the memory, how much will be occupied by array. For example, if I am going to have 5 elements like this in an array, right, my machine will allocate 4 bytes for integers. So totally 20 bytes will be allocated to store all these elements. Fine. What about linked list implementation? Actually you have to store the element, here is 4 bytes, and then you have to store the address of the next node. My machine allocates 8 bytes for addresses, right. So each node, we will call this as a node, each node in the linked list will occupy 12 bytes. So when I look at here, I have to store 5 elements, means then I have to allocate 60 bytes for this, right. So seems to be like it occupies more memory, isn't it? Yeah, simply if someone says that array implementation occupies more memory and linked list occupies less memory, that is not correct, okay. Then what should we go for? Okay, time complexity is almost same and memory required is also, you are telling more, and random access is not possible. Then when should we go for linked list? Yes, when should we go for linked list is, the first thing is when your memory requirement is going to change dynamically, when you cannot predict at all, right? Please understand that you are going to implement the ADT, right? And main will not be returned by you, the actual main. It will be returned by someone else. What I mean by main writing is application. Okay, the application, someone else will be using your disk, and his requirements may not be predicted by you at all, right? His memory requirements, his size of the data, everything is going to be decided by him only, right? If the memory cannot be predicted by us, then we have to go for linked list. If it is going to dynamically change, right, then we have to go for linked list, as well as when there is a sparse data. What I mean by sparse data is, suppose if you want to store a matrix, right, easiest way to store a matrix is a 2 cross 2 array, right? You can store it, but assume that if it is sorry, not 2 cross 2, 2-dimensional array, right? What about the dimension? If it is 2 cross 2, fine, only 4 elements. Even if 3 or 0, only one element is there, no problem. Suppose assume that I have got a 100 cross 100 matrix, okay, and out of this 100 cross 100 matrix, only 50 are non-zero. So look at the elements. Actually, when it is 100 cross 100, there are 10,000 elements. Out of 10,000 elements, 9,950 are zeros, and only 50 elements are non-zeros. In that case also, if we have to go for a structure like array, then we have to store lot of, we have to allocate lot of memory, right? But if I go for linked list, it's going to be less, right? We are not, our applications are not going to limit only to smaller data. We have to work with a large of data, and large of different kind of data, as I told you, 2-dimensional, 3-dimensional. The data may be of higher dimension also, and we may have a sparse data. In that case, we have to go for something like linked list. And one more thing is, we have to learn linked list, because this is the basic structure for most of the complex structures which we are going to deal with. That is another one biggest thing why we should understand linked list in a very clear way, right? Whatever we are going to do next, trees, or when you are going to have graphs, graphs will be list of list, right? So when we discuss, you will understand in deep. So linked list is so important that you have to learn it with clarity. First we will be discussing about single linked list, and then what is the drawback of that, we will go for double linked list, and so on, right? Okay, thank you.